A very good afternoon to all of you. Coming to an end to this course, I am feeling a bit nostalgic, bit sad, bit happy, and being a little, wishing a little more time with all of you guys. Because we had a great time in the last 1 week. So because we had such a great time, behind it there is a contribution of lot many people. So that's why it will be injustice if I do not acknowledge the contribution of many people who worked behind the camera, who worked round the clock, and who actually made this a success. So even before IIP got enrolled in the GIAN program, our director sir tried and had a lot of meetings with the Ministry of Education. A lot of proposals went through to the Ministry of Education. And after a lot of effort, our institute got enrolled in the GIAN program, which is a little milestone for us because that is actually giving us a lot of good exposure for we as an institute. So I am very much grateful for director sir to take that initiative, and not only that, from the very beginning of starting of GIAN proposal submission till now today, and after this also, there are a lot of support from director sir, which I am really grateful about. Apart from that, we have got good support from the office staff and many faculties of IIP, who not only extended their support in terms of lab infrastructure or in terms of volunteering students. So there are lots of participation from the students of IIP also, which made this program successful. But I think the most contribution that came is that you can see that our technical team, they are working round the clock. I can only describe things with all of you is that just before the starting, before the 3rd March, on the 2nd and 1st March was a weekend. And although some of us had a privilege to take a rest on the weekend, but our technical team, they worked round the clock. Round the clock, I mean to say that from morning 10 a.m. to night 10 p.m. So that is the level of dedication that they had. They had mastered the angle from which the camera will look good, from which the brightness will come perfect, from which the sound recording will have minimum noise. And it is such a good that we got appreciation from the Central GIAN Committee also, that this is the recording, the quality of recording is one of the best quality that we could offer. So I am very much thankful to everyone for the technical team for this. So that is it. And but I think that which made this event actually a reality, or that is that I had a chance, or I had my luck to meet Professor Vatanpour in a Euromembrane. The Euromembrane was, Euromembrane is a very good conference. It is a very famous conference for people who are working in the membrane area, allied area, etc. And all over the world, many people come there, okay. So it happens once in 2 years or 4 years, right? Once in 2 years. Yes. So a lot of people gathered there, a lot of membrane scientists, and in 2022, I had a chance to attend the Euromembrane conference in Sorrento, Italy, and I met professor there. But much before that, I have been citing his papers. I have been reading his works, and honestly, I knew him through his work much ahead of that. But I had a chance to meet him, and we discussed some possible go ahead, how we can take this networking together. And we submitted a proposal in GIAN, and it got successful. And I am so happy that I got a chance to get to Sorrento, Italy, to meet a lot of famous people in Europe, including Professor Vatanpour. So I am very much thankful for this opportunity and for his cooperation. So, but what I felt that I would have been totally handicapped in organizing this event is that if I did not had great help from two of my scholars. So Avigyan and Bogeshwaran and the three more students who have been working around the clock. I will not take their name, probably they will feel very shy, but all of them are, honestly, if they had not helped me, I could not organize this thing without them, right from the banner, right from the stationaries, right from booking accommodation or registration, lot of things. They had helped me a lot. So honestly, this is a great humbling opportunity for me to organize this event, and if we could make or take this relation that we have built in this GIAN course way forward, and if we can explore more areas to work on, if you feel motivated to work in this area, then only I will feel that this event was successful. This was worth our time. So given that, so it's a huge thank to all of you whoever have been part of this program. So, given that, I would like to take this opportunity to have a little token of honor or little token of felicitation for our foreign faculty or for our international faculty, Professor Vatanpur. So please join me in honoring sir with a small token of honor. Thank you, sir.
Thank you. Thank you.
So I request Professor Vatanpur to speak about his experience or his work a little bit. So, yes, yes.
I have a PowerPoint. Hello again. I would like to thank again from Dr. Raka and Andhra University and Institute of the Petroleum and Energy for hosting me. I am very glad that I am here and see your nice peoples from India, and I hope I can again come to India and I have very good days here. About my research area, I have a little PowerPoint, if open that. Excuse me, I have a PowerPoint. Mostly I speak about my research area during the lectures, and most of the reported data slides was related to my papers. As you see, I write in the bottom of them the reference, and there was my research area. I prepared these slides for faculty, dean, and others, but I briefly, the first one, Introduction to MEMTech. As you know, I am working in both Iran and Turkey. My family live in Istanbul, but I am 2 weeks in Iran and 2 weeks in Istanbul because I am an adjunct professor in Turkey. That means can I use both affiliation and both university? In Turkey, in Iran, I am also have good facility, but in MEMTech is the research in National Research Center in Membrane Technology, called as a MEMTech, is a national research center that have 9 big laboratory about the membrane fabrication in lab scale and pilot scale. We have almost most of the analyzation, membrane analyzers, instruments, and others. I have shown some pictures. Up to now, I completed more than 25 industrial projects about most of the membrane fabrication and some of the water and wastewater treatment that we use the membranes for the treatment of water. In Iran, we produce the RO and NF membranes in industrial scale. But we do not sell because Iran have problems with the USA, and therefore the export from Iran is very problematic. That I say Iranian can produce RO membrane modules and produce for internal use, but cannot export. But we have technologies, and I have 5 days work about the production line of the RO, and we can produce the RO TFC hollow fiber models in the industrial scale. And I have some projects about separation of gases, some projects I work about the MBR, and most of my research area was about the synthesizers of novel nanomaterials and use of them in the membrane fabrication. I show my facilities in Iran previously, and in Memtek in Turkey, we have a characterization lab, process lab, simulation lab, and module development lab, membrane production in industrial scale, and SEM, contact angle, HPLC, and others. In Memtek, Professor İsmail Koyuncu is the leader. He was 53 years old. And in Memtek, we are 3 professors, 6 associated professor, and 6 or 7 assistant professor. We have about 10 PhD students and about 20 MSc students. And every Wednesday we have a meeting, and our meeting is about 40 person. We have a good project now, one project from European Horizon about fabrication of a ceramic membranes for gas separation and separation of carbon dioxide from flow gases, because in the flow gases temperature is high, 200 centigrades. Therefore, we try to use the ceramic membranes as a support, and we coat the polyimide, high temperature polyimide on the ceramic for separation of the carbon dioxide. This is our facilities in Turkey for production of the membranes in 1 meter diameter. We have also a little one for production of in this 30 centimeters. We can produce hollow fiber membranes in both lab scale and pilot scale. We can produce nano fiber membranes, and Professor Koyuncu have a factory about the production of the reinforced hollow fiber membrane, and the company name is MEMSIS. This is Memtek Research. MEMSIS is a factory produce large-scale hollow fiber membrane for use in the MBR and export to many countries their products. We almost have all of the equipment for analyzing of the water and wastewater, and also porosimeter, optical porosimeter, contact angle, SEM, GPC, gel permeation chromatography, and other devices that we can use for example, characterization of the bacteria with confocal microscope, dynamic mechanical analyzer for test of the strength and stability of the membranes, and others. We have some portable systems for using these systems in the near of the river, in the near of the wastewater, for testing of them. And we can put these systems behind of a car and go to the location, and in pilot scale we can treat the water, and after approving our system, they contract with us for developing of these systems for them. Now, I am a 5-6 PhD students that most used in green chemistry. One is used now, their thesis is use of polylactic acid in fabrication of membranes. Another student is used deep eutectic solvents in fabrication of membranes, and we publish good papers in Journal of Membrane Science recently. We try to use deep eutectic solvent instead of hexane in interfacial polymerization, because the use of hexane is very high and relatively expensive. Previously, 5 years, 6 years ago, we used some new polymers in the fabrication of the membranes, but these are the synthesized polymers. Another polymer researcher synthesizes these polymers and give us, for example, 50 gram, and we prepare the membrane with this and usually compare with polyether sulfone PVDF membrane. Therefore, we use these polymers in the fabrication of the membranes. We use different green solvents. We now buy Siren, Tamisolve as a green solvent, and we use them in fabrication of the membranes with PVC, polyether sulfone, PLA. We use the new monomers also in the fabrication of TFC membranes for obtaining membranes with very hydrophilic functional groups that can cause to the more hydrophilicity. When you compare this monomer, this amine can react with TMC, and when we have a polymer, we have some hanged groups that can cause to the more hydrophilicity, and after fabrication of membranes, we can use these groups for grafting of another compounds to the membrane surface, and we published some papers about the use of these monomers. Also, I have collaboration with other groups about using of the software modeling simulation in the membrane process. Membrane process have a flow, and we can use CFD for modeling, or we can use density functional theory, DFT, for showing the interaction between the molecules and membrane surface. In this, with this DFT, we can approve our mechanism. When we say the membrane surface can absorb the molecule, a heavy metals, with DFT calculation, we can approve our hypothesis, our mechanism, or we can suggest new materials that maybe have not been synthesized. Some of these graphene are not synthesized and only is theoretical compounds. But we can assume that we have this graphene instead of graphene, and if we have this compound, for example, sodium can be passed from them or not. With calculation of DFT, we can say that sodium chloride, heavy metals can be passed or not. And maybe after 10 years, we can synthesize these nanomaterials, and in this case, our calculation will help to development of these materials. I've published some papers. One of my PhD students now work in microbial fuel cell. In microbial fuel cell, we integrated 3 different fields of science with together. Electrochemistry, because we have an electrode, and produce the electricity, such as fuel cell. We produce the electricity. We have a biological degradation, biological treatment. One of the electrolyte, anode chamber, with filled with microorganisms, and we have a biological reactor. And this biological reactor can produce the electron, can transfer the electron, and we have a membrane that exchanges the proton. Therefore, we have a biological treatment, such as traditional method, and when we have done our treatment, we produce also electricity, and in electricity can be used as a pumping, as the energy for aeration and others. Therefore, the MFCs, microbial fuel cell, is a novel method that produces their required energy for using the energy of the aeration and the pumps. In this study, we focused on the fabrication of the membranes, and another professor modified the electrode surface for increase the efficiency. And as a last slide, we work also in photocatalytic membrane reactor. In the photocatalytic membrane reactor, we have this reactor with volume of 10 liters that we have a membrane immersed in the solution. Some of studies is about the use of the flat sheet membranes, hollow fiber membranes with different pore size, with different materials. And we investigate the fouling behavior. All of photocatalyst is constant, and we only change the membrane properties and investigate them. In some case, we have a constant membrane, and we change the photocatalyst. We compare 5 photocatalysts in this system, or we change the condition, or we change the textile, and we can change, for example, the UV lamps. Our UV lamps can be immersed in the wastewater, and with control of condition, we try to increase the efficiency of the system. This was simply of my research area that I want to share with you. Thanks.
I would just like to ask you that thing, that in the photocatalytic reactor, the light intensity that you are taking the UV lights.
Yeah.
So
UV light or visible light. In some cases, we use photocatalyst that active with the visible light, and we use the visible light.
So what is the intensity range that you use, and did you ever see any local effect of heat generation on the
No, we use the low energy lamp, 6 watts, 7 watts. And when we want to increase the intensity, we use 2 lamps, 3 lamps. But the lamps can increase the temperature. And as you've seen, our reactor have jacket.
Yes.
And with water, we cooling the system.
Okay.
But no need in many times because the intensity and the feed, our reactor is continuous. Feed come and permeate goes. Therefore, this coming and going have a constant temperature. No any change. But we see these problems and prepare the reactor with jackets.
Because I showed you some reactor which is very similar, but
Yes.
we had a problem of heating, so we had put because our UV light is like in about 200 range.
Yeah, yes.
200 watt. So it was producing a lot of heat inside the so that's why we had to keep it outside.
Yes.
But we use a transparent system, transparent divider between them so that the light can pass.
Yes.
Yes.
I
So
see.
now
Very
that
nice
the-
reactor. Thank you.
Thank you so much. So the audience, if you have any questions, please. Okay. So please join me in thanking Professor once again for this.
I see.
I would like to request Professor to his certificate to join me in the certificate distribution.
Thank you.
So I will. So Professor Naga Chaitanya sir.
Give a photograph.
Yes, he is taking picture.
Thank you.
So I think Divya Malik and Rahul Gautam is not present. Vashist.
Good luck. Nice.
Sapna. I think Tarun is not present. Hari Prakash, not present. Okay. Manasha, not present. Avigyan. Vijay Lakshmi. Ranjit Kumar. Maghana Naidu, not present. Gita Priya. Lingaraju. Bogeshwaran. B. Jairam. Not present. Dinesh Palagumi. Tamirat Lamaro.
Thank you.
Rudra Sarkar. Komal Kumari, not present. Jai Shima, not present. Chandan. Ajay Kumar.
Good luck.
So I was asked to call him AZ. AZ, right? Am I speaking correctly? How should I pronounce your name? MJ. Okay, not AZ, MJ. Okay. So it sounds more or like Michael Jackson to me.
Good luck.
Okay. Harinina. Probably I'm pronouncing it wrong. Tejash is not present. Shatish. So next we have two online participants, Vishal and Karthik. So next we have Naini Thukla. I think Shatish can take on her behalf. Harshita is online. Rashmi Kumari already took. Mandar. That's all. Thank you so much. There, Muksha. Muksha person, what is his name? Sri Mahashwini. Yes. So for those who have joined online, it will be very great if you can send any representative to collect the certificate on your behalf, or if you have not, or if you could not join this, or otherwise we will share the soft copy form with you, or otherwise we can send for some postal, we can arrange for some postal service for you, but you have to drop me a message for that. If you would like to have a postal service for those who have joined online, for them I am speaking. So that's all, and I thank all of you. Please join me to, please stand up and join me for the national anthem. पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय जय जय जय हे. Thank you. So we can have a group photo once again, and then we will disperse for the day. Thank you all for joining with us. So shall we join for a group photo?
Yes.
Yes. Please join.
Come.
Daniel sir, please come and join us.
One photo is clicked and
Rudra, you come and you can give the camera.
Come here. Come, please, huh? Okay.
All of us are fitting? This is great.
Come you also, huh?
You can come over, Akhil. You can come this side. Akhil, you can come
Come
this
you.
side.
There is a problem.
I think you got it. You have a very complicated camera experience. So we can close the video recording. No, sir, we can close the video recording.